All right, another day, another Try Hack Me challenge. And this one is a fun one for you. If you were thinking about malware analysis as a potential career, this is a really cool one to dip your toes into. There's a little bit of Wiresharking with network PCAP captures. There's some event log analysis. And even better, there is some reverse engineering in decrypting of a payload based off of a binary sample. So these are all things you may do as a malware analyst or even a senior SOC analyst. So without further ado, let's dive into this one and have a little bit of fun today. All right, here we go. So just so you know, the setup I have for this is I have a Kali host that I'm gonna do most of the stuff on. And I'm gonna show you a simple way to solve the final challenge. And then we're going to move into my Windows malware analysis environment. And I'm going to show you how I would do this as a malware analyst. And I'll explain why as well. So let's go ahead and we have Masquerade up right now. It is a premium room. You will need a premium account on TryHackMe. You don't need to start an attack box or anything unless you want to do all of this in your browser, and you're totally cool to do that. So let's go ahead and download the task files. And in here, I've already done this, so you see them up here. What we'll have to do is just unzip the files. So we're just going to do this with a simple unzip command. All right. So what we have here is we have everything is unzipped, and it gives us the path that they landed in. And this is important because you may get lost in the command line. I know a lot of people starting out aren't comfortable maneuvering in there, so just pay attention to where it's going to be at and you'll be okay. So let's actually move into here and see what we have, and I'll do that in the command line as well. So we'll just cd to it, attachments, distro, and we'll just do a little ls. So right here we have a PowerShell Operational log. So these are logs that are generated when someone's utilizing PowerShell to do stuff, right? So pretty common scenario for attackers out there. And then we also have a PCAP file, and this is captured typically with your network appliances. Not every organization is capturing PCAPs, and even rarer is an organization that decrypts traffic. So HTTPS traffic that is encrypted, you have to have special tools and special setups in place to actually decrypt that. A lot of times in the labs we're working with just normal HTTP traffic, which isn't inherently encrypted. So keep that in mind here. All right, so let's go ahead and look at the scenario before we get going to see what we need to do. So we have Jim from finance received an email that appears to be coming from the system administrator asking him to run a script to apply critical security updates. So this is almost like click fixy in a way. Trusting the message, Jim executed the script on his workstation. Shortly after, unusual network traffic and system activity were observed. You have been provided with relevant artifacts to investigate what happened, determine the impact, identify how the attacker established the control over the system. So, a couple of things to keep in mind. So my guess is the PowerShell logs are from this critical patch that he did, and then the PCAP is for everything else that occurred afterward. There is an important note on this one. So there is real malware in here. However, everything can be done with static analysis. This is a very true disclaimer. So when we extract the malware samples, do not execute them on a system. You could do it in your own isolated malware lab if you have one, but you really do not need to execute anything unless you really, really want to. If you do, be very careful. All right, so we'll go ahead and check this first one, and it says we're going to dive in here. So what external domain was contacted during script execution? So what we can do, and this is a fun little thing that I found here, is if we had a Windows box, we could use some Eric Zimmerman tools to view this, and you could install them in Kali if you want. However, there is a really easy to use event viewer website. And I'll put it in the notes to this video so you can use it. And it's just called Oberman's GitHub.io. So it allows us to upload a sample file of Windows event log file, and it will allow us to just view it just like we were in Windows. Otherwise, we could do like a cat and look at the files that way. But me personally, I like to view stuff so that it looks normal to me. I don't know about you guys, but I am definitely not a computer. So let's go ahead and upload our event log file here. So just this PowerShell Operational.evtx, and we just want to make sure we are in the correct directory. We hit open, and then all of them load. So if you have done some log analysis, many of these things are going to be pretty common or pretty familiar to you. We have time date stamp, cool. We have the source, which should be PowerShell. Then we have the event IDs. So 4104 should be pretty familiar to everyone. Then we have the host name. So in order to see what's actually in these logs, we'll have to click through and actually look at them. So this one doesn't have much in it, and we're just going to click through until we see something of interest. So nothing super telling yet. We're still not in the fun ones, which are 4104s. If you haven't heard of these are script block logging logs, which allow us to see what types of commands and scripts were run within a PowerShell session. So right here, we just see prompt, which is pretty common when you initially kick off PowerShell before you execute anything. And then here we're seeing that he ran updates.ps1. This is very much in line with what he said, that it was a critical update here. So that sounds like we're getting closer. And these should be in chronological order for us. So prompt was created. So he started up PowerShell. He did a dot execution, and then this is what ran afterwards. So we see some string concatenation, some common, very, very common obfuscation techniques here. Now the question is, let's go back over here. The question is, what external domain was contacted during script execution? So I have another fun tool for you. And we are going to de-obfuscate this pretty quick, because that's kind of the trick with these obfuscation techniques, is that they're typically done with a common program. You could spend a really long time de-obfuscating them if you want. It's probably a fun exercise to do early on so you understand how these things work. But there are definitely tools, and there are ways to do this much quicker as you develop your malware analysis skills. So what we can do is just paste it in this tool, and it's called -1.skyblue.team. And you just paste it in here, and then we click Deobfuscate. And then what it does is it gets rid of a lot of the craziness that was in here, right? We see all this string concatenation and some stuff that may be confusing to most. What we did notice is that none of this stuff here was changed. That's still in there, but the string concatenation was removed. And we'll see why in a second, why that is the case. But the big question that we wanted to get was, what was the name of the domain? And that is api-edgecloud.xyz. So we'll just take that over here, put that in here, check. Then we want to know what encryption algorithm was used by this script. Now, I'm not a big cryptographic dude, okay? So I wouldn't be able to look at this and tell you exactly what it's doing. However, what we can do is we can say, hey, Google, help us out on this one. And we'll just go to AI mode and we'll ask it what type of encryption is being used here. Long gone are the days where all this stuff, it has to be memorized, right? utilize tools when you can to help speed things up, but definitely understand what's going on. So the reason why I utilize AI is because, one, I don't know the difference between these. And if you look at this, it doesn't look anything like the cryptographics algorithms you memorize in Security Plus or whatever certification you have. This is like in the weeds, the real deal. There's only a handful of people, I would say, that actually dive into this kind of stuff and really understand it well. So if it's your thing, do it. If not, do what I did. So the answer here is that the code is an implementation of RC4, so Rivest Cipher 4, a pretty common scheme. And you can see in here why Google decided that it was RC4, and it is correct. I encourage you to read through this and understand what it's talking about. But no, there are tons of different ones, a bunch of different types of encryption standards, and you never know what you're going to come across when you're doing malware analysis. So having a good general understanding of how encryption works is a really good starting point, and then being able to reverse it is the next skill, and we'll be doing that later, so stay tuned. All right, so we can put our answer in here, RC4, check. Great. What key was used to decrypt the second stage payload? Now, with this, we got it here. So this is the key, and we can analyze how it was utilized. So if we look to see where K was actually implemented, we can see it was down here in the actual encryption portion of it. So the RC4 area. And what you're seeing is just that a bunch of different variables here. We see them all over here, but K is thrown in this for loop right here. So this is indeed our encryption key. And so we can just throw it right into TryHackMe and get our answer. All right. Now it's asking, what was the timestamp of the server response containing the payload? This is one of the things that I highly encourage folks to understand what they're looking at and to figure out their next move based on the questions that they have to answer. So this is pretty realistic, right? When we're going through an investigation, we're asking questions. And based on the question, we have to know where to pivot. In this case, we don't know what the response is based off of PowerShell. We should understand that. PowerShell is the actual endpoint's activity. It's asking us about the server, which is not the endpoint. We can see when each command is executed at the endpoint, but we don't know anything about when the server is responding or any of that. But we do have PCAP logs that tell us that back and forth between the endpoint and server, which is exactly where our answer is going to be. So now we need to open up Wireshark to take a peek at our actual PCAP. So this is the PCAP here, and everyone should just be able to open it up. Wireshark should be installed for you already on Kali if you're following along. Now, what we need to look at is one more thing real quick, is that actually right here, we see that there's a download string. We see that this is executed. So we don't really understand, besides this being web traffic, we don't really know what type of traffic is going to be between the victim and the C2 server. So we have to kind of get an understanding of what that is. We can do that by looking in here to see what the protocol difference is. So we have IP protocol, version 4, hypertext transfer protocol. So we have quite a few packets of this and some data packets. So let's go ahead and take a peek at HTTP traffic. We'll scroll through, or actually we can use a filter for this as well. And let's just see what we have here. And we can just select it and then hit enter, and it's going to filter all of our stuff in Wireshark down to just the HTTP traffic. Now, here's the fun stuff. So it wants to know when the server responded. So what it's saying is we executed our script, our PowerShell script, and that's supposed to do a download, right? So it is supposed to be pulling down amd.bin. So we should see a web request, which we do right here, a GET request for that file. Now the response is right here from the server, which is HTTP OK. Now, here is a time frame, but it's not the correct format. What we can do is another little trick, which we can follow the HTTP stream, and in here we have the correct time and date stamp that HackTheBox is looking for. So we see the GET, we see the server response. Pretty straightforward. Let's go ahead and throw this in as our next answer. All right. So the next thing is it's asking us what is the SHA-256 of the extracted and decrypted payload. So we need to extract the payload and then we need to decrypt it in order to see what's going on. So let's take a peek. We have this here. And so there is another fun trick. So we see some transfer and whatnot going on here. Let's go ahead and go back to our previous filter, HTTP, hit enter. So what we're looking at here is all of the HTTP traffic again. What I want to point out is this is what it's telling us it wants us to pull down, decrypt, and take a peek at. Now, there are a couple of caveats here that we need to pay attention to. This isn't plain text, right? If we go back and look at our PowerShell, we see that there is an actual encryption cipher that was utilized. That's this thing. That's exactly what we're looking for. And the output's supposed to be this right here, AMD Finder SR.exe. So somehow we need to be able to figure out how do we convert that download to this exe so we can get a SHA hash of it. And this, again, is very common for an attacker, for malware situation. This is pretty common. So like I said, a really good box for folks looking to understand malware analysis. So two things. First, we need to pull that file because we don't have to actually download this file here at all. We don't need to do that. What we can do instead is extract it from the PCAP and then we can decrypt it ourselves. So let's go ahead and do that. So I don't know if you've seen this before, but we can do an export objects. It's going to be an HTTP object, and we can find it right here. So this is that file. And what we can do is actually, I'm going to create a new folder for us to work out of. Let's go do it right here. So let's go cd ... where we want to go, cd ... make dir, and we'll call it mask. Then we'll cd over to mask. Okay, so we're going to put our file in here. This will be our working directory for this, and I use mask because I'm going to jack up the spelling of masquerade. I already know it. Let's modify those permissions. Let's do chmod. You never really want to do 777, but whatever. Now we should be able to store a file. Let's try it one more time. Downloads, mask. All right. Now we should be able to just take a peek in there and we should be able to see our file. Great. Now we need to figure out how to decrypt this. So one of the tricks that old hands like to use when we're doing malware analysis is to just use the malware to do all the work for us, okay? And what I mean by that is that we need to figure out how to just simply take this and decrypt our current payload. So what we can do is we can literally take all of this, put it into a new file, and we can start working from it. What we don't want is this. Don't need it. And we're going to need to modify some directories And we're going to have to modify some paths so that it works out. So we'll just do /. We need to actually use Linux annotation so it works. Perfect. Now the big thing we need to do is we don't have to download anymore, right? We just need to essentially read the file from disk. So we can ask Google to help us out with this. So we can say, turn this into just reading the file. Make sure the output format is the resultant value is the same. So we'll do this. And then we'll just say the file is amd.bin. So this should convert, instead of downloading, just catting or reading the file and then piping it through the rest of the flow. So we can go ahead and grab this and we'll replace it with that. So what we can do, so as long as we run it in the same directory, we should be fine. So now this is going to flow all the way through here, and it should write the file out for us. Now, for those of you who may not know how to execute this, we could just Google it. Let's see. How do I execute PS1 file in Kali? And we should see something along the lines of PWSH, and Kali has the ability to run this. So it should be installed in recent versions, but go ahead and make sure you install it if you don't have it. And then all we need to do is run the command with -file and we should be good. So let's go ahead and save our file. We'll save it. We'll save it as PS1, not pi. All right, so we're going to type it as mass.ps1. We'll click save. Now we should be able to run this in here, just like this. And we should have new output. Now we see AMD Finder sr.exe. So it looks like it worked, but we need to confirm it and make sure the output file is correct. And we can do this with a tool called file. And this is built into Kali as well. So we'll do file amd.exe. And what we're looking for is, if it worked, we should see a .exe format as an output. If it didn't work, we wouldn't see it. And we have that right here, PE32 executable, and key information here, it is .NET assembly. That is going to come in handy very much so in a moment. So hopefully everyone is caught up to where we are currently. Now we need to do a SHA hash of this file so that we can answer the current question. So we just need to take this value. So SHA-256 sum is built into Kali. You shouldn't have an issue with that one either. Should be pretty straightforward. We'll just pop over here, drop it in. Boom, done. All right, so next thing is asking us a bunch of stuff about what's going on with the script. We could go find this URL in Wireshark, at least get the IP, and then we can turn it into a URL. There is a better way to answer all three of these, and we have to do that by actually doing some malware analysis at this point. So what we're going to do is we're going to decompile this .exe, and we're only able to do that because it is .NET. If you ever see a .NET file, that means we can use a cool tool called ILSpy to decompile it, and we can look at the code almost as if we compiled it ourselves and we have the source code. It's very, very close, not exact, but it's very, very close, and an amazing thing to find if you're doing malware analysis, because it's way easier than decompiling C++ or something like that. So let's do that. Now, what we have to do in order to do this is that we have to download the tool. So the tool is right here. Just grab the link. And all you have to do is download the version for whatever you're working on. So we can download the Linux version and it's on the system, and then we just unzip it, just like we did this one. I'll skip that piece, but just pull this down, unzip it, and we're ready to rock and roll. After that, all we do is, well, you guessed it, launch it. So let's go ahead and maneuver our way over to it. So we'll go into artifacts. So when you unzip it, you should see artifacts. And we just go into there and run the program. So cd artifacts. Just go in there, and now we should see that this is indeed our ILSpy, and we just need to run it. Let me scroll this up so we can find it right here. So this is the tool. We just need to run it. So let's do that. Should pop up once it's ready. So here we go. This is ILSpy, and again, it allows us to decompile C#, which is amazing. And all we need to do is, after we identify something as .NET, we just drop it in here and it let it do the work for us. So do this. We'll go up. We'll navigate to our downloads. We'll go to mask. This is our file that we decrypted, and we throw it in here. Now you'll see a lot of information related to additional files and stuff it needs to actually operate. That's fine. What we need to find is this right here, which is the file name. Once we find that, we're golden. And we can see some additional references and information in here, and a name called Trevor C2 client. So this is a C2 version or C2 file that's out there, which is all gravy. And this has all the information needed to actually run this program, right? This is literally the code. And so our question is, what is the URL that the client used to communicate with the virtual machine? So we have that right here by just clicking the top of this tree. This is the site URL. Pretty straightforward, isn't it? So we'll just copy this. We'll put it in TryHackMe, and then we'll move on. Now we need the encryption key and algorithm, and we need to pay attention to the format here. There's a comma. That is where the algorithm goes. So we need the key, comma, algorithm. We should be able to find that pretty quick. So here's the cipher. So this is the key, and then we need to figure out what is the algorithm, and we see AES key, create AES key. So that is indeed our algorithm. So we'll just put all these in there. And that one's a pretty quick one. All right, now time for the hard part. Now we have to figure out how to decrypt this code, or rather the encryption commands. So first, let's get an understanding of what the encrypted commands look like, and then we'll figure out how this C2 client handles it, and then we can move forward. So let's start here. This will tell us what's going on. So we have query string, GUID, so some pretty interesting stuff. Let's look at the connect person or connect function. Let me make this a little bit bigger for you folks. Oops. All right. We'll shrink this a little bit, just trying to give me some more space to work in here, a little bit more. All right, perfect. So what we have here is how it connects to Trevor. This is the important part because this is how it's talking back and forth, how the client is talking to the C2 server, which is exactly what we need to decrypt. So we can see here that the web request has /images as a directory and then a GUID as a URL parameter. And then it appends S to it. So the question is, what the heck is S? So S is the encrypted string that's encrypted with the AES key. So this is exactly what we need to decrypt. So we need to find all the communications with GUID in it, grab those, and then start working on the decryption mechanism. So let's grab those first, we'll put them in a file, and then we will attempt to decrypt them. So here's our file where we'll keep it. We'll open up our traffic here. And now we see exactly what we were talking about. GUID, 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 GUID. We got 2, 3, 4 of them. All right, so let's pull each one individually. The easiest way to grab these is to just right-click, copy value, and we'll just throw them over here. Well, at least that's how I do it. So that's 1 right here. Copy, value. We just need to make sure we don't accidentally truncate stuff. And I would tell you one of these is actually truncated. I couldn't decrypt all of them. I got 2 out of 3. Here we go. Sorry, I was getting a little click happy there. 3, and 1 more to go. All right. So now we have these. Now we have to reverse engineer the encryption function so that we can do a decryption function. So let's look at it, figure out how exactly it works, and then we can proceed to reverse engineer it. So what we have here is a test string, essentially, that is being passed to the encryption function. So let's check that out. So we have the unencrypted string here at the tail end of it. And then we have a from base 64 of the actual AES key that's also being passed as the first parameter. So with that, they get encrypted. And then after it's encrypted, then it converts that encrypted string to base 64 and then appends it to the end of the GUID. So that's it. So pretty small piece there. Now let's take a peek at the encrypted string. We can do that by just going here. And we can see that it creates a managed object, and then it utilizes this right here, which is the cipher, and then it converts that to base 64 string. So we basically have 2 sets of base 64 encoding going on, which can cause some issues if you're not paying attention. So we'll make sure we account for those. And we should be able to now relatively easily put something in place. So the one thing that you haven't seen yet is that there are a thing called IVs that are part of AES encryption that we will also have to account for, which is a 16 byte or 32 hex byte piece of this that is required in order to decrypt it. But we'll account for that as we build something out. So let's open up CyberChef and see what we can put together. So we have an empty CyberChef thing. So let's go ahead and put one of our values in there. This is our test string value. We know it is good. We see the padding on the end for base 64. This should help us. If we get it right, we should see that test string that we saw a second ago, which is here. We should see magic hostname. That should be part of the decryption value. All right, so we have this. So first things first is we obviously needed base 64 decoded. So from base 64, this will be the first thing. The next thing is, so if we're going in reverse, so this is this base 64, and then the output of encrypted string is also base 64, so we need to add one more right here, convert to base 64, so we need to add one more to it from base 64. Now, I would say, and this is what I chose to do, is to go ahead and turn it into hex so that we can actually see it and work with it. And that'll make life easier. So we can go ahead and do that. And we don't want any delimiters. So here we go. Now, the next bit is that we need to be able to take out the IV, which is going to be 32 bytes in hex. If we didn't turn it into hex, it would be 16 bytes. So there's a cool thing I learned while I was working this and preparing for this video, which is called register. And we can utilize it to basically extract those 32 bytes, hex bytes for us, and assign it to a variable that we can then use later, which is perfect. I love approaching stuff programmatically, and I've never used register until now. Let's go ahead and apply a regex that's going to get those bytes for us. There we go. So what we can see is that it is indeed adding the 32 bytes to a value, and we can use this $R0 later on. Now, what we do need to do now, we also need to remove these 32 bytes from this, or we're going to run into length issues when we actually start doing the decryption, right? If they're on there, it's not, well, it's going to be messed up. It's not going to be working the way it's working. So essentially we have 32 bytes of the IV, and then everything else is the encrypted text. So we remove those 32 bytes, which leaves us with the encrypted text, and then we can decrypt it and should be good. So let's do that. We can do that with drop bytes, and we'll go with 32. And now we just need to do AES decryption. All right, now we need to figure out the decryption piece. So we know the IV, $R0, good. Now the key isn't as straightforward as you may think. We actually need to do a SHA-256 of the key and provide that as the value. We can do that, open up another window in here. We can post it in here and then modify this to SHA-256 size. We get the value, and this is what we're actually utilizing as the key. And with that, we get our magic value. So our test dummy works. This is the first packet that was sent over. Now let's look through our other ones. All we have to do now is we just paste each one by one, and they decrypt. So some of them won't decrypt. That's okay, but most will. And with the last one, we get our answer. Now, let's go ahead and post this in here. We'll finish up the box. Let's do bonus time here. Take this off. Maybe that works. There we go. All right. So let me show you another way to do this. So one of the things we can do is replicate exactly what the malware is doing by just stealing the code and replicating the function. Sometimes that is much easier to do than to actually try to build it in a different language, right? So let me show you what I'm talking about. So essentially, I have a sample here where I just literally took out the functions from our malware sample, and I did that by just following the function calls. So I said, okay, I want to create an AES key because that's exactly what it does when it attempts to connect to Trevor. So this is the first initial one. So we see it does create AES key here. So I replicate that. Boom. So I add that here. But now I need to pull that function and put it in here so it knows how to use that function. I just copy it byte for byte. Pretty simple. Next, we need to figure out these other pieces. So we also have a full decryption function. So instead of encrypt string that we see typically, so right here we have encrypt string, we need decrypt string. So this is the opposite of encrypt, right? So we just pull that down and essentially replicate the same call that we have here, but with decrypt. And we do that right here, decrypt. Now the trick is, one, we need to pull in all of our bytes. Boom, boom, boom. I added them to text. We need to convert the key to base 64 here. And we don't have to do any of that funky shawing of the key because we just use its native function. So that removes the need to actually do that. Now the only piece to figure out is where's all the base 64 need to go. Let's just follow the code flow here, right? So we have our key, good. We need to base 64 decode our key because that's what's coming back from our key creation. See, base 64 encoded, but we also see it's decoded here as well. So we're just performing that. So we're good. So check parts 1 and 2. We have a key in a usable format. Now we need our encoded text. Great. All right, so we actually need to do this in sections so you understand what I'm talking about here. So let's first create a decoded string. So this is just simply the value that's decoded that's going to be pushed into the decryption algorithm. Let's create that. So we'll say it's going to be a string decoded because we definitely need a string. And we're going to say, we're just going to take all this part here because this is the actual bit that's going to go into the decryption algorithm. So this is all decoded and it is now a string. Now we need to do a string decryption, decrypted, and this is just going to equal and decoded. Boom. Now the encrypted piece is now decrypted and now we just have to see it. So we're going to do a console.write decrypted. With that, we should now see our output. And we do. Boom. So now we have replicated exactly what we've done in CyberChef. Not a problem. And we're good to go. Now let's do it for all the strings. Some of them don't work. Some of them do work. All right. So this is the complete thing done. And we can see a few things. We see the hostname, our flag. We even see IP configurations, and then we have one that's broken. I couldn't get it to work, but we have decrypted everything that we need to decrypt for this. So now you have two methods, both a CyberChef method and a, hey, real world, how would you do this? This is another good way to do it. You use the malware against itself and decrypt it. So hopefully you enjoyed this walkthrough from the eyes of a security professional with over 10 years of experience. Hopefully you learned a handful of things. And if you're interested in malware analysis, hopefully you got a peek into that world as well. If you're not following this channel, make sure you do that. Make sure you subscribe to follow all the cool content I'm putting out there. And make sure you let me know in the comments below, how did you solve this challenge? Did you do anything cool? So hopefully you enjoy this walkthrough from the eyes of a security professional with 10 years of experience. I have been a malware analyst. I have done forensics as well. Hopefully you learned a few things. If you're thinking about that malware analysis career path, hopefully this shined a little bit of light in that area. Now, the last couple of things for you to do is do that like, share, subscribe thing for me and drop a comment of how did you solve this TryHackMe challenge. See you next time.